Hello learners, in this lecture we will see what is retarder and what is the practical application of that in the concrete. So we'll try to see the English meaning of a retarder, say retard. So anything what you delay or hold back in terms of progress or development is called as a retard, right? So now we'll try to see the definition from the concrete technology point of view. So to understand it better, let us say I'm giving you this softy cone to eat. Let me do it in this way. I'm giving you this softy cone to eat, and I've told you to eat it after 15 minutes, right? So you have two options. Either you hold it like it is and try to eat it after 15 minutes, or so if you try to eat it after 15 minutes, what is going to happen? It's going to melt down something like this, and you'll be left out with nothing to eat, right? The second option, what you can do is you can take the same softy cone, and you can put it back in the refrigerator, and after 15 minutes if you take it out and if you try to eat, it will remain in the same position, right? Whatever I gave you, and after 15 minutes when you do the refrigeration and when you took it out, it is remaining in the same state, right? So so basically what I have done, I have delayed the melting of this, right? Do you agree with me? What I have done by keeping it in the refrigerator, I have delayed the melting of this, right? So in the same way, whenever I want my concrete to delay the setting of a concrete, I don't want my concrete to set quickly. I want to delay the setting of my concrete. In that case, what I need to do, I need to make use of the retarder. So I'll give a small practical use of this. Let us say you want to do a concreting in a place. Let us say this is a place what you have, you're working at a site now, right? Let us say the name of the site is something B, and you want to do the concreting here, and then you don't have concrete available here. You're bringing it from the batching, you're bringing it from the RMC plant, that is ready mix concrete plant, where the concrete is prepared. You're going to bring it from there, and let us say your batching plant is somewhere in this place, and we'll call this as A, and the distance between this batching plant to your site is, let us say it is somewhere close to let us say some 400 kilometers. Like I'm taking some rough value, usually it won't be 400 and all. Okay, we'll go for very short. Okay, we'll take 200 kilometers, right? Yeah. So to cover this distance from A to B, which is 200 kilometers, let us say you require minimum 3.5 hours to cover it. 3.5 hours, right? So that means if I'm preparing a concrete at the place A, and by the time the concrete is going to reach to your place B, what should happen? My concrete should not set, right? Because we know that initial setting time of a cement what we had got was somewhere close to 85 to 100, and the final setting time should happen within how much? 10 hours, should not be greater than 10 hours. But here what is happening? But here your 3.5 hour is gone in transporting the concrete from from A place to B place, right? So but once your concrete reaches the destination B, it has to be in a workable form. That means your concrete should not set. So in that case, what we need to do, we need to add certain agents in the concrete while preparing in the batching plant, so that it is able to remain in the same position. That means I'll try to add retarder in this concrete, so that even after 3.5 hour, when the concrete reaches to the destination B, it will remain in the same way like it was prepared. Now if you try to relate that with this example, see, I told you to whatever softy cone I had given you, and I told you to eat it after 15 minutes. Even after 15 minutes, the state of the uh, softy cone was same like what I had given you 15 minutes back. That means what you had done by keeping it in the refrigerator, that means you actually retarded the melting of this, right? So same thing we are going to do with the concrete also. Whenever we want my concrete to do the transportation from one place to another place, when I want to delay the set, so practically what we have done, we have delayed the setting of a cement, right? So that setting of a cement will be delayed, can be delayed with the help of a retarder, right? I hope this basic understanding is clear why the retarder has to be used, and under what circumstances we need to use. One I already explained you, during the transportation, when the distance to be covered from the batching plant to the place where the concreting has to happen, if the distance is like 3 hour, 3.5 hour, in that case you have to try to add retarder, so that your concrete, whenever it reaches, it will be in the workable form, right? Yeah. So other than that, there are few other points, we'll try to see them as well. Yeah. So this admixture are added to retard the setting process, as we have understood. So one question that comes in our mind, see, already during the manufacturing of a cement, we have added the gypsum, right? And why that gypsum was added? The gypsum was added for the very same reason, to delay the setting. Because if you don't add a gypsum, then the then what will happen? Yeah, tricalcium aluminate will react with water and quick setting was happening. Since I didn't want that quick setting to happen, I had added gypsum. So when I added the gypsum there, again, why do I need to add retarder here? So this retarder what we are adding, no, it is added from the environment point of view. That means, see, retarder are used to counter the accelerator effect or the surrounding temperature. So usually what happens when you do the concreting work in the very hot regions, let us say you're working in a Dubai, in a Middle East country where the temperature is somewhere close to 55 degrees Celsius. Since the temperature is very hot there, then what will happen? The cement is going to get, I mean, the concrete is going to get set quickly. But I don't want my concrete to set quickly, because if I have a big raft foundation to be casted, then my concrete should be workable, right? By the time I finish my concreting, my concrete should be workable. So if the sweating is going to happen, I can't even place my concrete. So in order to retard that, whenever we have very high temperature, in that case, very hot temperature, we try to make use of the retarder. Especially in case of the oil well construction, if you have seen the oil well constructions and all, there the temperature will be somewhere close to 200 degrees Celsius and all. So just imagine what will be 200 degrees Celsius. If the temperature is somewhere close to 200 degrees Celsius, then the moment you bring the concrete, it's going to get set, right? But by using retarder, we'll try to delay that setting, right? So this retarder we are adding from environment point of view, right? But gypsum what we have added is from that chemical reaction point of view. Yeah. So the next point is that by using the retarder, the setting time can be delayed up to 72 hours. That means if you're adding a retarder, there are certain percentage for adding a retarder, you can delay the setting even up to 72 hours. 72 hours comes out to be three days. Then let us say I've added a retarder in my concrete now. Up to 3 days my concrete will be workable. That means it's not going to set, and only after that it's going to set, right? So based on our requirement, based on the places where the concreting is done, we try to make use of the retarder. But uh, uh, the basic idea is to retard the setting process. Now coming to the example, you can use gypsum. Already we have seen how the gypsum is going to play its role. Then you can make use of the tartaric acid. Even a sugar is a very good retarder. If you try to add sugar in the concrete, it's going to delay the setting process. And even the starch is also going to delay the setting of a concrete. So these are the few retarders what we have. So other than that, there are other retarders as well. We'll try to see them. Yeah, you can see it here, no? What is written? Duplast RTPL is a maybe, yeah, this is what they have written. Dubond is a name of a company which manufactures this. It is written here, retarding admixtures. Similarly, you can see it here, right? So wherever there is a requirement of this admixtures, we try to add them. Yeah. Now coming to the functions and how it has to be done, how it has to be understood. If you want to put it in terms of point, you can try to understand this. We'll see that. The first is retarder. The function of the retarder is to delay or extend the setting time of a cement paste in the concrete. We already seen that. These are helpful for concrete that has to be transported to a long distance, like I mentioned, from destination A to destination B, which is around three and a half hour. In that case, we have to put a retarder. Otherwise, halfway, by the time you reach half of the destination, your concrete is going to get set, right? So in order to delay that, we need to put, and helpful in placing the concrete at the high temperature, which you have already seen. So the most commonly used retarder is a gypsum. It is mixed with the cement during its manufacture. The amount of gypsum used in the cement depends upon the type of a job. We already seen that. If you want a quick setting cement, in that case we don't use gypsum only, right? Because I want quick setting. And if you want a low heat cement and all, we have seen how it has to be done. Yeah. But the gypsum used as a retarder in the cement requires greater inspection and control in the concreting work. Yeah. So other than that, what all are the use of the retarder? We'll see them. The first is to work to overcome the accelerating effect of high temperature on setting properties of the concrete in the hot weather conditions. It's a same thing what we have seen. To delay the setting of a cement when concrete is to be placed in a difficult conditions. So difficult conditions in the sense, it's the same thing, like hot weather conditions, or let us say you have some big raft foundation and all, right? So when we have a raft foundation, when huge amount of concrete is to be placed, then let us say you're starting your concreting from this place, and it's around, let us say, 9 o'clock. Okay, it's, let us say, it's morning 9 o'clock, and this much by the time you reach here, okay, by the time you reach here, let us say the time is somewhere close to 4 hours, right? Yeah. So in that case, what you need to do, you have to make use of the retarder so that your concrete is workable even by the time you reach to the end, right? So these are the uses of the retarder. So other than that, like I mentioned, when the concrete is required to be transported to the long distance in the grouting oil wells, where the depth of about 6,000 meter, temperature may be around 200 degrees Celsius, and cement grout is required to be in mobile condition for about 3 to 4 hours. Next, commonly used, we already seen calcium sulfate is also called as gypsum. You can make use of the starch, you can make use of sugar, cellulose product, and other than that, you have these things like acid or salt of acids like lignosulfonic acid, hydroxylate carboxylic acid, what is that? Yeah, mucic acid. Then we have acetate, and then we have tannic acid. So based on the requirement, we try to make use of all this retarder. Now coming to the effect of this, we'll see the last point: effect of adding the retarders to the concrete mix. What is going to happen when you try to add a retarder? The Give me a minute. Yeah. So the delay in the setting of a concrete is achieved by using the retarding admixtures. The mechanism of the set retards is based on the absorption principle. So this is the principle on which the retarder work. The large admixture anions and molecules are absorbed on the surface of the cement particles, which hinders the further reaction between the cement and the water. That is, it retards the setting, like we have seen in the gypsum. So what actually happens? So these are my cement particles. These are my cement particles, let us say. So when you try to add retarders, cement particles, and when you try to add gypsum or the retarders, they are going to form a layer around the cement particles. So this layer will not allow the water to react and start the hydration. So that what will happen, the setting also will delay. If the hydration process is delayed, obviously the setting is going to get delay. And once the effect of this gypsum or the retarder is done, after some time they'll stop losing their effect, and then the water starts to react. So that will have enough time till then. So that we can do our whatever work we are supposed to do, right? Yeah. Yeah, retarder keeps the concrete plastic and workable for a very longer time. Now, a small quantity of sugar, even a 0.05% by mass of a cement, can delay the setting of a concrete by about 4 hours. If you're taking even a 0.05% of a mass of a cement, I mean the sugar, it can delay your concreting work by around 4 hours. So 0.2% by weight of sugar increases the final setting to 72 hours. A large quantity of sugar, say 0.21% by mass, prevents the setting of a cement. So based on this principle, the sugar will form a kind of a coating around the cement particles. As a result of that, the delay is going to happen, and that is why we classified sugar as a retarder, right? So even if you're working at a site, and let us say you are a site engineer in charge, and if you find that you have to delay the setting of a concrete, then even you can try to make use of the sugar and all. But again, that requires some careful inspection by the expert, because by our own we cannot take any decision, because concrete is not that easy to understand, right? Even though you delay the setting now, you have to see it from future point of view, whether it is going to gain a good strength or strength or not, and whether the strength gain is going to happen or not. So with the help of expert people, we can try to experiment all these things. Yeah. Yeah, so one basic thing what you need to understand between the accelerator and the retarder is that in the accelerator, what was happening, the surrounding temperature was very cold. The surrounding temperature was cold, and there the setting was not happening. In order to make a quick setting, or in order to make the setting proper, we were using the accelerator. But in retarder, what was happening, in the retarder, the temperature itself is very hot. The surrounding temperature is very hot. So if the surrounding temperature is very hot, my placing of a concrete will happen quickly, that is setting of a concrete will happen set quickly. So if I want to delay the setting of a concrete, then what I need to do, I need to make use of the retarder. So this is a common difference, or a basic difference, why the accelerator has to be used and why the retarder has to be used. Yeah. So other than that, yeah. So that's it about the retarders. So we'll see you back in the next lecture. Thank you.